So P is your, I'm going to say present value or initial value. And then A just stands for future amount. That's it. Because what we're solving for is A, which is just your future amount, what happens after you compound. Okay. I will say that this is a reminder that this formula is based off what, A equals P1 plus R over N times T. The reason it looks like this one up here is because N is usually 1, which just means it's just compounded once a year, right? So in this case, we use the top one because, again, it's just going to equal the same thing. We just plug in 1 and it equals the top. But just make sure that when you're compounding, you use this formula. Okay? Compounding means that they'll increase the amount in your investment. So usually they just do it once a year, but sometimes there are investments that do it multiple times a year. Quarterly means 4 times a year. Quarterly means 4 times a year. So, Khalid, how do I plug this in? Okay. 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 So exactly like you said, you put 0.1 for the rates for 10%. It's for 10 years, and so you get 1,000 times 1 plus 0.1 to the 10th power. Just as a reminder that the reason we do 1 plus is because 1 just represents your initial amount. So when you multiply by 1, you get back your initial amount, and then we add 0.1. So that represents we're adding on 10% to our original amount. Okay? So the 1 represents your original amount, and then the 0.1 means I want to get the math, which represents not only the original, but also the new amount added on to the original amount. So it's 10% more than the original amount. So then, in your calculator, you can just type 1,000 times 1 plus 0.1 to the 10th power, and you get your answer. You can just round to the nearest second decimal, so 100th place, and you would get 2,593.74 cents. And if they asked us how much money did you make, you could just go ahead and subtract 1,000, because 1,000 was your initial investment, and you can get 1,593.74 cents. So you can see that if I was trying to calculate how much money I made off my initial investment, then I would have made 150% of my original investment, right? I made the same amount plus actually almost 160%, which is pretty crazy, in just 10 years. Any questions there? Any questions there? Okay, I'm actually going to turn to the flip side. So if you turn the page, I'm going to go over the last couple problems here. Okay, so on this side, I'm actually going to show you that. Let me actually bring up the other problems. Let's see. So on that problem, what we had originally written for number 2 was 1,001 plus 0.1 to the 10 years. So on the backwards, or on the back, it says there is a scenario which is true for everyone, which again we've said that if you just keep your money depreciates, right? Every single year your money gets less and less. I think currently the depreciation rate is 1.7, something like that. So that means that for every dollar that you have, you actually lose 1 cent and 7/10 of a cent every year. Okay. So what we would do is we would take this original equation, and it's saying that we're going to lose 3%. So this means that every dollar that you have, you actually lose 3 cents every year. That's generally what happens. So that just means that the buying power of your dollar is worth less. So what I want you to do is I want you to have your original amount. You can actually even take exactly the same equation you wrote, and all I want you to do is now to subtract the depreciation amount. So 0.03, we're going to subtract the 3% from our original amount. So if you look at the previous problem we just did, what I'm doing is I'm continuing off of that to say, well, if I also depreciated the money, I can see how much my buying power, how much my money is actually worth now. Okay. You can actually just click second entry, and then you can see here that it types the same amount that I just wrote. And then you can actually type second delete, which makes you insert, and then you can just write minus 0.03, and basically you're just adding in a new portion to what you typed in before. And then if you press enter, you can see that we get our new amount, which is 1967.15. And if we minus 1,000 to see how much money we spent, we can see that we actually get 967.15. So you can see that I think the previous amount we had was about 16,000. And you can see when we factor in depreciation, we actually only make $900, right? We only actually make $900 worth of your original amount. Okay. Pretty interesting, right? Pretty interesting idea. And again, this is part of the reason why, if you look back in like the 1950s, houses might have only been worth like $20,000, is because their buying power or their dollar was worth that much more back then than it is now. Because of inflation, our dollars are actually worth less, but they're not worthless. Okay. Okay, anyone have any questions? So all you really do is you take your original equation, you just subtract the percentage that you're depreciating, and that's the new amount you would get. Okay. So you basically have exactly the same equation. I just want you to subtract the percentage amount, the decimal amount. And for the one that you're compounding, you can also do the same thing and then divide by 4. Okay? And we'll do that tomorrow. Okay, any questions on this one, on the depreciation? Okay, the last two problems I do want to go over are these ones right here. I just want to make sure you guys remember how to solve these. So for these ones, does anyone remember what is my first step here? What is my first step? And if you don't have a graphing calculator, you actually will need one for the test, or you just have to set everything up and just wait for someone to finish the test and borrow the calculator. If you still need to borrow one, I have the forms, so just feel free to ask me, and you can borrow it from the library. Okay, does anyone remember what is my first step here? What am I supposed to do? How do I calculate this? Does anyone remember? Okay. So the first thing you do is you turn on your calculator and you enter everything in. So you go to Stat. If you see on your calculator, there's that button called Stat on the third column, second row. You click Stat right here. You can see that it gives you this page. You're going to go ahead and click Enter, or you can just press 1, and it's going to let you edit the list. You're just going to type in all the values. So you can see here I have 1, 2, 3, 4, 5. Those are all my X values. And then my second list is going to be 0.6. It's going to be 4.1, 12.4, 27, and then 49.5. Okay, after this, you can just go ahead and press stat again. So you're going to press the same button after typing in your list. So I'm just going to press the same button. I'm going to the same page. But instead of pressing enter, I'm actually going to go right to the one. So you can see that I'm going to the one that says calculate. And you could either press 0 at this point, or you can go ahead and scroll down if you're really unsure you're pressing the right one. You can see that EXP-REG is the exponential regression line. That's what we're trying to calculate. Again, you could either press 0 or you can just press enter, and you see that we're right here. So the next thing you could do is you could just scroll down, go to calculate, and you could just press enter, or you could hit enter a couple of times. Both work. And you can see it calculates the the exponential regression line. And you can see that the formula is y is equal to a times b of x. So we're just going to round to the nearest 10th. All right, sorry, 100th. So it's going to be 0.34, and then you're going to have 2.92 to the x power. Okay. So basically, just off of that, we just calculated the whole thing through our calculator, right? We didn't do any of that by hand. We just put all of that in our calculator. And then it tells us to solve when x is equal to 10, right? It tells us to solve when x is equal to 10. So all we do is we just plug it in. So 0.34, 2.92 to the 10th power. And then we just put that in our calculator. So 0.34 times 2.92 to the 10th power. You solve, and you get 15321.72, and that's our answer. That's it.